everyone. Professor Michael Scanlon here. So today kicks off our Celestial Objects in the Night Sky week. And since it's Sunday, the day named after the sun, I figured we'd start off with the sun. So what's so special about that big glowing ball in the sky? Well, a lot apparently. It's actually a really unique type of star, and I highly recommend you get into as much of it as you can. I always encourage you to look into more than I'm giving you. And today we're just going to hit a few of the awesome highlights of this, our home star. So let's check it out. Our sun is a star. It's a very active star. Okay, it is bigger than two-thirds of the stars out there, so it's not average by any means. It's also unique in that it's a single star. Stars typically come in sets. They are generally parts of groups or binary or trinary systems or what have you. The sun is really big. In fact, its total makeup makes up about 99% of the solar system. So if you take all the planets and everything, that's all just 1% of the solar system's mass. So the sun is really big. Here is the sun and the 8 planets, and they're all to scale. No, not to distance scale, but to actual just size scale. And you can see that there we are, little beautiful blue marble, third rock from the sun. Um, we are incredibly small next to this thing. We're small next to the other planets that are the Jovian planets, but we're really small compared to the sun. So the sun is really known, or one of the things it's known for at least, is sunspots. Sunspots are just regions where the sun's surface is actually cooler than the area around it. If it were by itself, if I were to take this sunspot and put it out in space by itself, it would still glow just like a light bulb. But because it's cooler than the area around it, it's actually dimmer than the area around it, and that makes it look black. Fun fact for you, it was originally thought that those sunspots were windows into the sun, and so they thought the sun was dark on the interior. I have a couple of websites I want to show you and let you check out. Spaceweather.com is really cool. It gives the current conditions in our solar system. So the sun does produce a wind, and that comes from its outer atmosphere known as its corona. So the sun is layered. It has a core, a radiative zone, a convective zone where convection occurs. Remember that from one of our previous videos. And then it's got an atmosphere that's made up of a chromosphere. It's pink. And that's from the hydrogen. And a corona. Corona is Latin for crown. The sun does not have the virus. So the solar wind comes from the corona. Okay. And you can have holes in the corona, and that's where you get a lot of solar wind. So the sun has no sunspots. It's actually in a very quiet period right now. The sun goes through like this 11-year cycle. And I highly recommend you. I mean, there's just loads of information here. It's incredible. Part of what you're going to see is who and how strongly can you see or can see an aurora. So that's pretty cool. And you can check the um, northern hemisphere and the southern hemisphere. Sorry. So here's our coronal holes that we have. There's two of them right there. There's one up at the top that I can see that's not labeled. And this is where the solar wind is going to like blow out, and material from that particular coronal hole should reach Earth somewhere around March 30th or 31st. It takes a little while to get there. So what about the structure of the sun and its energy? Does it take, just a couple of days for energy to get it? No, that's different. Right? So the sun produces a lot of light and a lot of heat and things like that, a lot of energy. That energy is produced in the core for the most part, and then travels outward through the sun to the photosphere, that's the surface of the sun, and then into space. Once it gets to space, it takes a little over 8 minutes to get to Earth. It's traveling at the speed of light. The coronal wind isn't traveling that fast. It's traveling fast, but not speed of light fast. Here's a fun fact for you. The sun is so dense that the light, the energy produced, takes over 1,000,000 years sometimes to reach from the core to the surface. So the light you're seeing and the heat you're feeling today from the sun was produced before humans ever set foot on this earth. Homo sapiens, I should say. So, something else that you would see on spaceweather.com, near-Earth asteroids. There are just a few Not that many. Potentially hazardous asteroids, and don't worry about any of these. They're really not that big. But these are things that just could potentially hit Earth. So spaceweather.com loaded with information. Also, SDO. This is something I reference a lot in my classes when I'm teaching astronomy, when we're talking about the sun. These have hours old images of the sun. And here's one where you can see the coronal hole there at the bottom in this darker blue splotch. Oh, there's a better picture of it. And then a little bit of a hole at the top in the corona. So Solar Dynamics Observatory, these are hours old images, and they do have a gallery with older images that are more dramatic and everything. So I highly recommend them. I use them all the time in my classes. I highly recommend spaceweather.com. And if you have an astronomy app, check out and see if there's any information on the sun on that. All right, everybody. Until next time, stay safe. Hope you enjoyed it.